Hello everyone, welcome to this NPTEL SWAM online course on space environment and its effects on orbital spacecrafts. So, in the last class, in fact the last two classes I discussed satellite orbits, its geometry and how to determine the satellite velocities as well as the period of the one revolution in one orbit. Then I discussed different types of Earth's orbits which are useful for satellite applications, namely the low Earth orbit, the medium Earth orbit, polar orbits and the sun synchronous orbit. We also discussed the high Earth orbit, namely the geostationary Earth orbit as well as the geosynchronous Earth orbit. So, in today I will start a new topic, that is the segments of the satellite. So, a satellite systems, what are the subsystems it contains? These things we will refer frequently when we will go for discussing the space environments. So, we will start with the satellite segments and we will see that the satellite has namely three segments, that is the launch segment, then the space segment and the ground segment. So, today we will discuss the space segment, and in the space segment we will discuss the mechanical the system, or it is also called the mechanical mainframes, and in mechanical mainframes we will discuss what is the structure, what is the types of the structures satellite uses, and what is the thermal control system, what is the need of the thermal control system and what are the subsystems used under the thermal control system. So, what is a satellite system? So, satellite system basically it consists first the launch segment. So, using launch vehicle, the satellite is put in its the desired orbit. So, this is the first segment. Of course, in this course we are not going to discuss about the launch segment, but just for the sake of completeness I am mentioning it. So, we will be discussing the space segment followed by the ground segment. So, this is the launch segment. Launch segment means basically it is a launch vehicle. So, there are different types of launch vehicles. Since this is not included in this course, I am not going to discuss. So, what we will be discussing, that is the space segment and the ground segment. So, any satellite system, it consists of a space segment. Space segment means the spacecraft, and then it will have a number of the stations called the ground stations, and one station it is called the telemetry, then tracking and command. So, it is TTC, it is written here. So, this one we will be discussing all those subsystems. Okay. So, considering the space segment means this, it is basically the spacecraft. So, in the spacecraft basically the spacecraft consists of two subsystems. One is called the mainframe, the other is the payloads. So, what is payload? So, payload means the scientific or the technological instrument which is carried out on board the satellite, and their purpose it can be the communication. So, those transponders or the transmitter and receivers we use on board the satellite, they are called the communication payload. It can be navigational payload. So, navigation means when the satellites are used for the for finding the position or tracking an object on the surface of a planet, especially surface on the earth. So, we call it a navigation payload. Then there can be a payload which is called the remote sensing payload. Remote sensing payload means this instrument by which you can study the atmosphere of a planet, then the tomography of the surface, and then what is the vegetation, all these things can be studied using a remote sensing payload. Then there can be telescope. So, telescopes are used for the astronomical purposes. So, that also if you put a telescope on a spacecraft, so we call it a payload. Then there can be the spectrometers. So, different types of spectrometers are used to characterize the material, what is the wavelengths associated with it. So, this can be a spectrometer. Like that, there can be other types of the payloads which would depend on the what are the functions you want from a particular satellite. Now, what is the mainframe? Mainframe this here basically two types of mainframe. One is the mechanical and the other is the electrical mainframe. So, mechanical mainframe means the structure over which we put all the instruments or all the subsystems by which the satellite can operate. Then there will be a thermal control system. So, thermal control system means I want the temperature of the satellite, different subsystems, the temperature I want to control it. So, the system which does that thing, that is called a thermal control system, and then there is a subsystem called the mechanism. So, mechanism means by using mechanisms there are various types of movements of the satellite. Movements means sometime it may be required to unfold something, or maybe the folding, or maybe I want to rotate some part of the satellite, some instruments. So, these things are done by using mechanism. The next is the electrical mainframe. So, electrical mainframe, the most important electrical subsystem is the power system. We need power system to energize the different subsystems of the satellite. Then I need a communication system. Communication system means the satellite to the ground station communication. Then we need to have a data handling digital system. So, that will do a onboard processing, that means the coordination of the various subsystems. For that we need a data handling digital systems, and then we need to have attitude and orbit control system to do for this, that is the station keeping of the spacecrafts in its designated orbit. Then we need the telemetry, tracking and the command, that is another very important subsystems under the category of electrical mainframe. So, that is needed for to know what is the health of your satellite, and suppose what is the position of the satellite. Once you know all those things, then we can monitor it, we can correct it. So, that is the function of the telemetry, tracking and the command. Now, we will discuss the mechanical mainframe, that is the structure. So, as it is very clear, the structural frame that will house all the essential subsystems required for the desired operation. Okay. So, this if you see this schematic diagram, it shows one of this one frame. So, over that frame you can put your solar cell, that will be the power system. Then there may be required some rotating wheels, then there is maybe some receivers. So, all the systems you can populate it on that structure. So, that is basically the structure of the satellite. So, you see here, this is the structure of the satellite over which the solar panels are deployed. So, this is your solar panel and this is your payload, and this is the satellite. This is also called the bus or the satellite structure, bus of the satellite. Now, what should be the properties of the material of those structure? Now, you see, whenever we put a satellite in the orbit, basically it is the vacuum, there is no atmosphere, there is no greenhouse effect. So, in the presence of the sunlight, when the sunlight is fallen on it is illuminated by the sun, the spacecraft requires a very high temperature. And when it goes to the night side, when it does not see this sun radiation or the sunlight, it becomes very much cool. So, under that condition, there will be the thermal expansion and the contraction of the material, and this can lead to the material deformation. Okay. So, what is that essential properties of the material? The material should have the ability to maintain its size and shape despite of the temperature changes, because there is the temperature changes, very frequent temperature changes. So, this is known as the dimensional stability. So, the dimensional stability is very important here, and also we will see that we have not discussed those harsh environment of the spacecraft. So, the material also should be suitable enough which can withstand the spacecraft, the harsh environment. Then whenever the satellite is launched, so the satellite experiences a lot of vibration loads. So, you can assume like that the acceleration or the force on it sometimes it can be 10 times that of. So, the acceleration what it can have 10 times more than that of the acceleration due to gravity, this is the g. So, means the force is at the 10 times when it undergoes that launch the vibration during the satellite launch. So, again this material should be strong enough, the strength of the material should be strong enough to withstand this type of the launch load. So, what is the requirement? The material must maintain its integrity and it should not break or bend or deform under the immense forces of the satellite when it is launched. Even when it reaches the its orbit, under this the temperature cycling, there should not be any deformation. So, what is required for that? The physical properties like the density, thermal expansion and the radiation resistances. So, it should meet all the specified values of these parameters. Then the mechanical properties like modulus, strength and stiffness, those also should be satisfied. For space grade material, it has to satisfy all these physical as well as the mechanical properties. And another requirement is that the structural material should be it should be lighter. It should have all the properties at the same time. It should be lighter, that the launch cost can be minimized. More the mass of the satellite, more will be the launch cost. So, a material which is very much suitable for the satellite application, that is called carbon fiber reinforced plastic CFRP materials. So, it is widely used in spacecraft where the need of weight reduction is extremely important, and they are having the excellent specific strength and the elasticity of modulus as well as very high dimensional stability, and they can maintain, that is that thermal deformation is minimal, that is the coefficient of thermal expansion is minimal as compared to that of the metallic material. These are made of carbon fibers with resin. So, those resins are mainly epoxy or poly epoxides resin. So, this shows one of this structure, or this is called the satellite panel. So, this shows the photograph of a satellite panel. So, you will see that the skin or the front face, this is made of the CFRP. So, it can be the both side can be the CFRP, the face skin. Okay. So, this point already I said, that is the carbon fiber has very high dimensional stability due to its low thermal expansion coefficient, and it is approximately 10% that of a metal. Now, to have its more reduction in weight, what is done? The CFRP is used along with the honeycomb core. So, honeycomb panels are ideal for strong and the rigid design in the lightweight package. Of course, this lacks thermal conductance needed to effectively spread or the heat transfer, but there are the techniques, we will come to that. There are heat pipes are embedded in the CFRP panels, so that you can have an effective thermal management. So, this I was telling about, you can see this is the CFRP, this is the face skin and this is the honeycomb structure. So, this again this shows also this part is shown here. Okay. So, this material can be Kevlar, even this can be even aluminum also, or even it can be made of the CFRP. So, there are different types of the honeycomb materials available. Now, very important subsystem of that under the mechanical mainframe, that is the thermal control system. So, in this illustration you can see this spacecraft is covered by some foils, gold plated foils, and even you can see that this is the solar panels. Solar panels also, whatever the ground page the solar panel you have seen, the color is different here. So, this is all because here it needs some special care. So, that is called the thermal management or the thermal control system. We will come to that one by one. So, why I need that thermal control system? So, all these system, whether it is electronic system or whatever power system, whatever we use in the spacecraft, they are having a specified temperature range. It will work within that temperature range. Okay. So, the thermal control system will ensure that the satellite operates or whatever the subsystem operates within that temperature range. So, this is one purpose, that is whatever the subsystems you are having, that should operate within that its specified temperature range. This also applies to the structure of the satellite, though the CFRP and other things is we were telling that it is thermally very stable, but still it is having a range. So, we have to operate the satellite within that range, so that this precise alignment and the attitude stabilization sensors and all these things functions properly. Now, we will discuss what are the different types of TCS, what is the principle of the thermal control system. So, why it becomes challenging, especially for the spacecraft, because in the space when it is effectively it is the space is vacuum, there the three mechanisms of the heat transfer they are not valid there, especially there is no convection, because there is no air particles, there is no gas particles. So, in that way the convection is minimum, or you can neglect that heat transfer method. So, only the heat transfer mechanism will depend on either the conduction or radiation. So, this becomes the heat transfer mechanism, and from it becomes a little bit critical because of the extreme vacuum of the space. So, what is the second law of thermodynamics? It states that the direction of the heat flow is invariably from hotter to the colder body. What does it mean? That the spacecraft will receive the thermal energy from the sun, and whatever the heat energy reflected from the earth and moon. So, depending on the satellite surface temperature, the satellite will either receive or transmit thermal energy from the earth and moon. So, the last sentence has been shown by this illustration. So, you can see the satellite will have its own heat generation. Okay. Then it is receiving the solar radiation, as well as it is receiving the reflected radiation. Reflected radiation means this is also called the albedo radiation, as well as the earth will have its own radiation, that is called that infrared radiation. So, there is whatever the temperature of the satellite, if you want to maintain a specified temperature, there should be a balance between all this, whatever the heat lost as well as the heat gained. So, these things can only be done when you use the a thermal control mechanism. So, what is the principle of that thermal control? So, what is the requirement? The requirement is that you should be able to maintain the mean temperature of the satellite. So, how you can get that? That has to come from the equilibrium between the heat generated internally, the heats absorbed by the surfaces of the satellite, and the heat radiated by the surface of the satellite. So, there has to be an equilibrium. The temperature continuously, it should not increase, or it should not continuously decrease the temperature. The temperature should remain within some limit. So, how this can be done? So, these things are done by adjusting the thermal conductivities between various parts of the satellite. It can be either to favor the heat exchange by conduction between one point to the another. So, I can increase the thermal conductivity. Okay. So, this can be done by the choice of the material which is having very good thermal conductivity. Then what is the surface I am using, that surface, and what is the section I am using, and there can be some of the devices like heat pipes. So, I will explain what is heat pipes in the coming slides. To limit the exchanges of the heat by the use of, you can use the insulating materials to limit the exchange of the heats. So, by using the the conduction between one point to the another, you can stop it also by using the insulating materials. Another way of that is the making use of thermo-optical properties, such as the emissivity and the absorption of the surface to favor. So, what is the example? The extraction of heat by radiation. So, heat suppose the heat is generated inside the satellite. So, you can reject it, and at the same time you can minimize the captured heat. So, whatever this heat it is receiving, so that it can minimize, and at the same time whatever heat is generated, that is able to reject it by using some of these components. It is called the optical solar reflector, or also in short form it is called OSRs. So, in some cases some local sources of heat can be provided by using the electrical heaters. So, suppose the temperature is going too down, so then the heaters can be switched on, so that the temperature is raised. So, the thermal control is realized either passively or actively with a preference for the passive control, because passive control is it is simple, and it is having the cost is lower, as well as it is having higher reliability. So, this is desirable to use a passive thermal control system. So, what is the passive thermal control system? So, passive control system, it does not use any power. So, no external power is used, and it is based on the absorptive and the emissive properties of the surfaces. Okay. So, the power radiated per unit area of an ideal black body. So, this is the formula where sigma is the Stefan Boltzmann constant and T is the temperature of the body or the black body. So, depending on the material used, the values of the, that is the absorptivity alpha and the emissivity epsilon, this vary between 0 and unity. So, the ratio of generally the ratio of this alpha by epsilon or the absorptivity by the emissivity, this is of prime importance in determining the mean temperature of the surface exposed to the sun. So, already I said the passive thermal control maintains the component temperature without using any powered equipment. So, the passive systems are typically associated with low cost, low, that is it is low volume and lower weight, and this reliability is higher. And especially for the very small or the small satellites or the especially for the cube satellites, these types of the thermal passive thermal systems are very much suitable. So, what are those? So, one is the MLI. MLI means it is called the multilayer insulation. Then you can use different types of coatings, then surface finishes, then there can be some interface conductance, then heat pipes, sunshades, thermal strips, interface materials, louvers. So, there are different types of passive control system. We will discuss a few. So, what is multilayer insulation MLI? So, here a type of high performance insulators which uses multiple radiation heat transfer, that is the barriers, means the heat transfer it will not allow us to retard the flow of the thermal energy. And the individual radiation barriers usually are thin polymer films with vapor deposited metal on one of both the sides. So, you can see there is also, this is insulator and both the sides of the insulators are generally metal coated. So, in order to get it reflects or the most of the thermal radiation. So, what is done actually there is a stack of the layers are used, that is why it is called the multilayer insulator. So, you can see there are the different layers used, and when you used suppose the one layer is having 90 to 99%. So, whenever you use suppose 10 layers or more than that, so you can increase that is the reflectivity can be increased to a whatever it can be near to whatever the we needed is the 100% effective barrier. So, next one is the optical solar reflector. So, optical solar reflector, as I said, it is capable of rejecting the heat generated by the spacecraft, and it also it is capable of reflecting the whatever the energy it is receiving it. So, it is having both the properties, good properties. So, you can see there are some heat rejection areas. So, these are basically the OSS. So, these are connected to the high power devices of the satellite. Now, there is one very important components used in the satellite, this is called the heat pipes, and heat pipes is basically it is a sealed tube, and so it is evacuated and a small amount of liquid is introduced. So, what happens whenever the liquid comes in contact with a hot body, so what the liquid absorbs the heat and it evaporates, and then it flows, and when it comes in contact with the cooler body, so it gets condensed and it gets the heat, the latent heat from the, that is it gets the heat from the hot body. So, in this way the heat is controlled, that is that is heat transfer or that is a particular, if there is a hot spot. So, that it will the heat pipe will be able to they transfer that heat to a cooler point. So, that way the temperature is maintained. So, there are some thermal control coatings are also used just to increase the either the reflectivity or the absorptivity of the material. So, like when the black paints are used to increase the absorption coefficient, and the white paints are used to increase the reflectivity. Now, there are few active controls. Active control means like using a electrical that is a heater, a resistor. So, where the powers are put. So, that way you can use active control systems. So, these are electrical resistance heaters, Then there can be the cryocoolers, especially for the type of the some sensors like IR sensors, cryocoolers are used, where the temperature is something like needed temperature is something like 120 degree Kelvin or it is below. So, there can be thermoelectric coolers. So, the type of the whenever you can use a thermoelectric devices to get the cooling. So, some two dissimilar material, whenever you pass the current, the temperature gets, you can have a lower temperature. Then fluid loops again is an active. So, there is a fluid pump through which the fluid is circulated to have the heat transfer. So, this is whatever we wanted to talk about what is the satellite segment. So, we discussed the satellite segment. So, we discussed the especially the space segment, and in space segment we discussed the structure of the satellite, and the properties, what should be the desirable properties. So, we have seen that how this CFRP material is very much suitable as a structural material for the spacecraft. Then we discussed about different that is the thermal control system. And here we have discussed both passive as well as the active thermal control system. So, let us conclude it here. Thank you very much.